Hey guys, and welcome to this video on AVL trees, more specifically on AVL tree insertion. So we want to show the state of the tree after inserting the value 26. And below here, we have our AVL tree that we're going to use, that we're going to insert the value 26 into. All right, so what's going to happen is we're going to run into a case, more specifically the left, right, or LR case, where once we insert that value 26, our AVL tree will be unbalanced. Currently it's balanced, and we will have to do something called a left rotation here and then a right rotation there in order for our tree to be balanced. And of course, our tree will become in a state like that first case here. All right, so I'm going to go ahead and get rid of these arrows. Now, below here, I have our tree from the previous page that we're going to insert the value 26 into. So just remember that an AVL tree is nothing more than a self-balancing binary search tree. So that means that all of the parent nodes' children whose values are less than or equal to its parent will be to the left of that node, and all of the children whose values are greater than its parent node will go to the right of that parent node. All right, so let's go ahead and insert 26 into our tree. So we check to see if 26 is less than or equal to 58, and it is, so we're going to go to the left of our tree. So we reach 17, and then we check to see if we check to see if 26 is less than or equal to 17, and it's not, it's greater than 17. So it's going to go to the right of 17. So we reach the node that contains the value 39, and then we check if 26 is less than or equal to 39, and it is, so it's going to go to the left of the tree. So we're going to insert the node that contains the value 26 in our tree. Now, of course, I set this up such that the tree is currently now unbalanced, but you should always check the balance factor first, and then you will notice that you will need to balance the tree or you will not need to balance the tree depending on what that balance factor returns for your tree. All right, so the balance factor basically states that if we have the height of the left subtree and we subtract it from the height of the right subtree, and the value is equal to either -1, 0, or 1, then our tree is balanced. Or if the height of the right subtree minus the height of the left subtree equals -1, 0, or 1, then our tree is balanced. So we can use either one of those two equations. So let's check the let's check the balance factor of our root node. So our root node, let's see, the height of the left side is 1, 2, 3. So I'm gonna get rid of those markings. All right, so we have 3 minus 1. So we get 2. And 2, of course, is not within that set of -1, 0, or 1. So we know that our tree is unbalanced at this particular spot in the tree. So I'm going to go ahead and erase this equation for the balance factor. And I have a video on AVL tree balance factors as well that you can watch if you want a little bit more practice with that. So we now have decided that our tree is indeed unbalanced. So our tree is in that first state of this left-right case. So we can imagine that the 58 is like the 5. We can imagine that, I'm going to use this black here. So we can imagine that the 17 is like the 3. And then we can imagine that the 39 is like the 4. Okay. And then, of course, we have 3. And then we have 26. And here we have 75. And that looks to be it. So I guess here what we would have is null. Okay. And so now that you can see how this relates to that left-right case, now we're going to do what's called the left rotation to get it in that second state. So let me just kind of use these arrows here to show a transition or a transformation of our tree. So now our tree becomes 58, and then 39, and then 17. Oh, look like I'm running out of room here. So actually I'm going to rewrite this and move it over a little bit more. All right. So again, we had 58, then 39, and then we had 17, and then we're going to have this. Okay, so we still have our 75 here, and here we're going to have our null. I guess I'm going to write the null in green this time. I didn't do it over here, but it should be green. And our B will be the 3 still here. And now our C is still 26. Okay. Now we just need to do a right rotation. And that will bring the 39 up to our root. That would bring 17 to the left. And that would put 58 to the right. And then we're still going to have our 3. And we're going to have our 26. And let's see. So we're going to have our 26 here. We're going to have null. And then we're going to have our 75 over here. So now that we're done with this, we can see that our tree looks like this here. It is balanced. And of course, you can just put circles around the triangles if you prefer that that way. The triangles here just represents subtrees. So a subtree can just be one node as well. So thank you guys. I hope this video wasn't too confusing, and I hope it was well explained. If you have any questions, please leave them in the comment section below. Don't forget to hit that subscribe button and that like button for more videos. And as always, guys, please share it, and thanks for watching, and I'll see you all in the next video.